For this particular system, notice that our first equation has a less than or equal, so it will be a solid line. Our second inequality will have a dashed line, since this is just greater than and not greater than or equal to. So we'll have a solid here and a dashed here. This first one happens to be in slope-intercept form, which is y equals mx plus b. So we can tell it's crossing the y-axis at 4, and the slope will be 2/3. We're going to use that to graph it. So it crosses the y-axis at 4, and since the slope is 2/3, from this point I can go up 2, and then forward 3, and find another point. I could also go down 2 and back 3 to find a point if I wanted, because a double negative is positive. Let's connect those with a solid line. After we connect those with a solid line, we need to figure out which side of this line needs to be shaded. We can do that by testing our point right here at the origin 0, 0. We can do that because it doesn't go through 0, 0. So we'll replace the y and the x with 0, 0 and see if it works. So I have 0 less than or equal to 2/3 times 0 plus 4, which means 0 is less than or equal to 4. And that's true. And since the point we plugged in is on this side, this entire side would be true. So for this equation, this side here would be the one that we shade. Now, we're not looking for just where this one gets shaded, but for where this one's shading overlaps with the second one. So let's go ahead and graph the second one. Since your second one happens to be in standard form, we'll use our intercepts to graph this. So let's first find our x-intercept. On our x-intercept, y is 0. So we'll replace the y with 0 to get negative 2x plus 3 times 0 equals negative 3. Or negative 2x equals negative 3. If you divide both sides by negative 2, we find out that x is 3/2. So the x-intercept for this one is going to be at 3/2, 0. Let's plot that point. 3/2 is 1.5. So that point's going to land right here. Let's find our y-intercept for this particular line. Our y-intercept will end up having our x be 0. So we're going to plug in 0 for the x here to get negative 2 times 0 plus 3y equals negative 3. Or 3y equals negative 3. When we divide by 3, y ends up being negative 1. So we have a y-intercept at 0, negative 1. Let's plot that point. It's right there. Now remember, this line needs a dashed line, so we're going to go ahead and dash that line right across there, going through our two intercepts that we found here and here. Now, we need to know if we should shade over here or shade over here. So let's go ahead and use our 0, 0, which is our origin, in order to test whether we would shade on this side. So we're going to plug in 0 for our x and 0 for our y into the original inequality and see if it works. Negative 2 times 0 plus 3 times 0. We want to know if that's greater than or equal to negative 3, which gives us 0 greater than negative 3. Well, that's true. And since this point was on this side of that line, and it was true, this line would shade up here. Now, notice that that would make the overlap in between those. Since the overlap is in between those, our solution is in that section there, and that's the only part that we want to shade on this, because we're looking for where it works in both equations and not just one.